Hello there, ROS developers, and welcome to the day 3 of the Learn to Debug ROS week. So today we are going to be debugging and reviewing a little bit some code related to most of it transforms and also URDF. Yes? So if you are interested, stay with me because this stream is for you. So see you in a moment. Let's start. Well, so here we are another day. We are on day 3 of this Learning to Debug ROS Code week. I am Alberto. I am the head of education at the Construct. And as I've just said, today we are going to be reviewing some code related to TF, to transforms, and also a little bit related to URDFs. So this is what we are going to be doing today. First of all, I want to thank you all for being here one day more with us, trusting in us for learning ROS. And before I start, as always, I'm going to have a quick look at the chat to verify that everything is fine. You can hear me fine, see me properly. So, and also to say hi to you guys. Okay, so let me have here, you can see hello everyone. I see Mauricio says, Alberto was filling his Mac with good coffee. Yeah, you're totally right. Here is my Mac. Plenty of coffee, so I hope everything is going to be good today. All right, we all missed you. I see here Gaurang. I also missed you all, guys, so thank you very much. Yes, it refreshes every day. Okay, so guys, let me know. Are you listening to me properly? Everything is fine? Yes? Okay, I suppose it is, because if not, you would be already complaining in the chat. I know you very well. So audio and video are working. So it's engineering nation. Okay, fine. So as always, I'm going to start by sharing with you the project for this for today's class. Yes? So I'm going to go grab it here real fast. Let me come here and look for it. Here I have it. I'm going to copy it and paste it here into the chat. Let's go. All right, so I have passed it here to the chat several times. I can see also, yep, it's clear, listening fine. Okay, excellent. So, as always, I'm going to switch now to the ROS Development Studio screen. So, as always, open the ROS Development Studio screen, which I have right here. And if you already have an account, log in. If not, just create an account. It's free and it will take you just some seconds. So go for it. Then once you are logged into the ROS Development Studio, you just copy paste the link I have sent to you in the chat, and you are going to get this project here. Learn to Debug ROS Code day 3. Yes? So I'm going to start opening mine here. Once you have your project, you click here on the open button and open project. As simple as that. Yes? Then, meanwhile, my project is being loaded. I want to remember also today that we have our Discord server, which you can join. You can come here at the bottom right corner in the ROS Development Studio. You can see this button here, which is ROS Study Group. Then if you click here, this is going to take you to the Construct, to our Discord, where you are going to be able, you can see here we have already 330 members. Then within here you are going to find people who is interested in ROS, in learning ROS. You are going to be able to discuss with them about different topics, about live classes that we are doing, about this training week, for instance. If you have some doubts, you can ask them there, and you will find many people who is in the same situation as you. And people who is interested in ROS and in learning and developing with ROS. Yes? So I really encourage you to have a look here and join our Discord server. Yep. Then let me have a quick look here at the chat to see if everything is going fine. Yeah, it's clear. You can see here Ricardo is telling me to share the project 13 times more. I hope that with 3 is enough for everybody to get it. So let me know, guys, any problem with the project? Have you been able to get it? And are you opening it, loading it? Everything is fine? Yes? I hope so. All right, so let me come here and see, let me close the Discord server, by the way. Close this, and here I have still loading my ROS Development Studio. So meanwhile, I'm going to open here the Robot Ignite Academy to remember you guys that we have our online academy. Here, you can come as well from the ROS Development Studio screen, main screen here. Okay, my project is opened. So here from the ROS Development Studio, you can click here at the left menu to ROS courses, and this is going to take you to our Ignite Academy. Yes, which I'm going to explain right now in a moment. So, first of all, the thing I'm most interested right now is that all of you are able to properly open your project. And before I start with the class, so you are going to see the Jupyter Notebook automatically opened as always, and you should have this day 3 notebook here prepared. Yes? So let me come back here. Project is opened. Okay, project is open, loaded. Excellent, excellent. So here we have day 3, then some course requirements that you need in order to follow this class. As always, you need some basics of Linux and Python. Yes? For this, the best way to get this knowledge, if you don't have it already, is to check our online courses, which you can find here in our academy. Yes? So here we have the free courses for Python 3 for robotics and Linux for robotics. Yes, they are completely free, so if you want to learn more about these topics, just check them. Click here on Start Course and you are going to enter the course. Yes? And also, if you finish these 2 courses and you feel confident enough, you can come here to the Code Foundation for ROS path in our featured paths, and you can go for the exam. Yes? Even if you pass the exam, you are going to get a certificate, which you can link, put or display, for instance, in your LinkedIn account. Yes? So go for it, guys. Then also, you should have a little bit of knowledge here for ROS basics as well, I would suggest, because I'm going to be assuming some things, yes? So at least some basic concepts of ROS you should have. And here we have 2 amazing courses, like the ROS Basics in 5 days in both Python and C++. So you have them also in the academy if you want to learn ROS basics in a very practical, easy and fast way. Check these courses because they are really good. So, whoop, I don't know what I have done here. Let me just refresh this. I have zoomed here. I'm not very used to work with this computer. Let me try to unzoom this. No. Let me see. Okay, I think the best I can do here is to open this again. All right. Yes. There we go. Now I'm going to set it. So this computer is completely new. I'm not used to work in this computer. This computer, I use it only for the live classes, and sometimes I'm touching here things which I shouldn't, and I'm messing things around. All right, so we are back at the previous state. Then, first thing we are going to do in order to set up everything for today's class. So today we are going to be working with the P robot, which is this humanoid, kind of humanoid robot. Yes, then in order to start the simulation, you are going to need to come here to the Simulations menu at the top bar here and click on the Choose Launch File button. Then now here, you're going to be able to select from different launch files, and in this case, you're going to select the debug_day3.launch. Yes? Then you select this one and click on the launch button, and this is going to automatically start loading the gazebo simulation, which we are going to be working with during today's class, during today's training. Yes? Then this is going to start loading here, and if everything goes properly and as expected, you should end up with something like this, with this robot here. Here my textures weren't loaded properly, but never mind, I can just refresh this so that it renders everything again. Let me click here. There we go, much better. Yes, then here I have my robot, my P robot, which has loaded properly, as you can see. So I want you all to be in this state, yes, with ROSject opened, Jupyter Notebook here at one side, with the text prepared to start working, and here at the other side, the gazebo simulation with the P robot, which we are going to work with today. Yes? Then, let me know, guys, are you all in this point? Everybody is in this same point? Because let me remember you. 1 second, I'm going to go back here to my pretty face. So, as always, as I'm always saying, I want you to be working with me, yeah? So, I am going to be explaining some things, doing things here in my project, and I want you to be doing the same, yes? So, as I'm testing things and modifying files, adding things, removing things, so as I am working here, I want you to be working and practicing with me, yes? From your homes, but practicing all together at the same time, because this is the way that you are going to really grasp the concepts and really learn. Yes, not just by listening or watching to the screen, but by practicing with me. Yep. All right, so let's go back here and let me have a quick look at the comments before I start to see that everybody is on the same point as I am. Loaded, open, hello, hey, just on time. Ready, yep, yes, ready. Everything loaded, ready. ROSject and simulation loaded. Okay, great. So everything is going perfect, I can see. All right, so let's start with the class then. Let's go for it. So, first of all, as you can see, this project contains one package inside its Catkin workspace, which is named debug_day3. Yes, so in order to visualize my Catkin workspace, I'm going to open here the IDE, which is going to allow me to visualize all my workspaces and packages I have here in my project. Let's see. Then it says this package contains a launch file named p-robot-control.launch. Yeah, it's not peer here, it's p, yeah, p_robot_control.launch, which starts the control system for the Pi robot. Okay, I can see here that my IDE is not loading properly, so in this case, what I'm going to do is to click here on the refresh button, yeah. If in your case you get this same problem here where the IDE keeps here stuck loading, just click here on the refresh button. I'm going to do it right now, and this is going to resume the IDE and show it properly. Yes? Here I have it. All right, excellent. So here I can see all my workspaces, and inside the Catkin workspace, inside the SRC folder, I can see here my debug_day2. It says here, by the way, day 2. This should be day 3, but doesn't matter. Folder with a launch file here, which says p_robot_control.launch. Yes? So far so good. All right, then it also says, in this case also, it's important to note that within the simulation_workspace, yes, which we have here, yes, so here in the Catkin workspace we have the debug_day2 package, but in the simulation workspace here you will find all the files related to the gazebo simulation of the robot. Yes, so all the files related to this robot, to the simulation of this robot. Yes? Then, This is important to know because you might have to check them in order to solve this problem. Yeah? So, in today's class, we are going to have to review here some files related to the simulation, which you are going to be able to find here inside the simulation workspace in the SRC folder in a package which is named here p_robot_package. Yes, we are going to go back here, but know that you are going to be working with simulation workspace and CAD/CAM workspace. Yes, because until today in the previous classes we were only working in the CAD/CAM workspace, so that's why I think it's important to point out this. Yes, then the main purpose of this class is to be able to correctly publish and read the states of the joints of the robot as well as the transforms. Yes, so this robot, as every robot, has some joints, as you can see here, and it has some transforms which indicate the relation between these joints. Yes, I don't know if you are familiar with TFs or not, or joints, but every part of this robot, you can see here this hand, the elbow, etc., the head here, all of this is composed of links and joints which connect all the links. Yes, then these connections are represented as well as transforms. Yes. Okay, anyways, if you don't understand very well this concept, you are going to do it right now, so don't worry about this. Then we are going to keep going, and okay, let me, before continuing, let me see if everybody, no problem. Sorry, I'm late here, Brahim. While it is late, okay, well, better late than never, yes? Okay, excellent, so no problems, great. Then, okay, so as always, we are going to start working by opening a web shell. Yep, there we go. Then here we are going to source our CAD/CAM workspace. Then, the first thing we are going to do is to execute this launch file we have here, the probotcontrol.launch, because this will set up all the control system for our robot. Yes? So it will start publishing all the states of the joints as well as the transforms. Yes? This is what this launch file is supposed to do. Then I'm going to grab this command here and paste it here and execute it. So let me do this right now. There we go. And this has started executing some things. As you can see also, the joints are now fixed in the robot. Yeah, so no error here. Apparently everything is fine. Yeah, I cannot see any error. Started the controller spawner, loading controllers for all the different joints, as you can see here. So apparently there is no error here, right? So now with the control system up and running, we are going to try to get, let me, by the way, open. Okay. We are going to try to get the transform from the right hand of the robot. Yes, so from this hand here in the robot, yes, this hand, this blue box here is the, no, sorry, this is the left one. I think this is the left one and this is the right one. Anyways, so we are going to try to, yeah, this is the right one. Yes, right and left. Then we are going to try to get the transform from the right hand, which is this one, to the base of the robot, which is here. Yes, this, I don't know what this is. Yeah, so this here is the base of the robot. It's a point, in fact, which is here at the center of this cube, yes, which represents the base of the robot. Then we are going to try to calculate and get the transform between this base to this hand, which basically is going to tell me the position of this hand with reference to the base of the robot. So more or less it would say something like, okay, so this hand is 1 meter up, 1 meter to the left, let's say, and with this orientation in respect to the base of the robot. Yes? So this is basically the transform between the right hand link to the base of the robot, which is the base link. Then this, we can get it using this command, ROS1 tf echo, and then here we specify the two links that we want to get the transform from. In this case, it's right hand link and base link. So I'm going to open another shell here, and I'm going to execute this command. So let me execute this command. And here I'm starting to get an error. Yes? So what does this error say? Okay, let's read it. Failure at whatever. Exception thrown. Right hand link passed to lookup transform. Argument target frame does not exist. So it's telling me that this link does not exist. Yeah? Here in the notebook we can see what we should expect from this command. So if everything was properly, we should get something like this, indicating me the translation and the rotation of the hand in respect to the base robot. Yeah? So for instance, this translation, which is the thing we are going to focus on, it tells me that this meter is 10 centimeters up in the z-axis, 17 centimeters up here in the z-axis, then 12 centimeters here, minus 12 centimeters in the y-axis, and minus 12 centimeters as well in the x-axis. This is what this is telling me, and this is telling me the rotations in quaternions, in radians, and in degrees. Yeah, the rotation of this hand in respect to the base of the robot. Then this is what we should expect to get. But instead, we are getting this. We are getting this error, which is saying, hey, this right hand link you are specifying does not exist. I cannot see this. Yeah? So basically this looks like a problem in the TF. So it looks like the TF, the transform of my robot, are not being published. Yes, this is what it looks like. Then I'm going to ask you now, all of you, what do you think we should do now? So where should I start debugging this? What should I do? What do you guys think? What would you do in my case? If you have this problem, what would you do? Let me know, and I am going to read your answers and start debugging the code from what you tell me. So I'm blindfolded right now, yes? I want you to start guiding me through this problem. So what is the first thing you would do here? What would you start debugging? Let me come here real fast to the comments to see what you guys are saying. Okay, here Maru Singh is saying, why is my robot white? Yeah, refresh it. So in case your robot appears white, click here on the refresh button, which is going to refresh the window, and it's going to render all the colors properly, yeah? So let me... the video got stuck there, says Carol. Okay, try to refresh it, or maybe... Here is playing normal. Yeah, I don't see any error here, so maybe it's some problem with your connection or whatever. Try to refresh the video. Okay, yeah, it's going again, thanks. Okay, great. Then I can see here, Richard Boyce says, check the URDF. Very good idea. Here, Maya Robot says TF3, also very good idea. Gaurang says, check for the publisher and subscriber. Which ones? Come on, I don't know what publisher and subscriber you refer to. Check if the name of the link right hand is right. Okay, yeah, that's a good point, but where do I check this? Where? Pedro Xavier is saying this. So then check the launch file. Says Kamat, look for TF3. TF3. Okay, I can see a lot of people which is asking me to look for the TF3. Then let's start from this point. Okay, so I'm going to check the TF3. How I'm going to do this? Well, I'm going to do it by generating a file here in my source folder. This is going to be with this command, rosrun tf beer frames, yeah? I'm going to paste this command there to the chat in case you want to use it and you don't know it. This is the best way, the way I prefer to check the TF tree. So I'm going to execute this command, which is going to generate here in my source folder, in Catkin Workspace SRC, because it's where I am. This is going to generate a PDF file. Here, you're going to see it right now. There you have it. Frames.pdf. Yes, here I have the file. So now I'm going to download this file here. And let me open it here. I don't see if you are seeing this. No, you are not seeing it, I think. Are you seeing this? Yeah, I think you are seeing it. Yes, okay, great. Then, as you can see here, we have no TF data received. So basically, there is no TF being published for my robot. Okay, so this makes sense. If there is no TF being published in my robot, it's logic that my right-hand link is not being found by the system. Yes? So I'm trying to check here the transform between two links, between two frames, but there are no transform published, so it's impossible that I get any result. Yes? So this makes sense. Now, we know that our robot is not publishing the TFs. So, why it's not publishing the TFs? What should I do now? What should I check? What is the element in ROS that publishes the TFs in a robot and in relation with URDF files, let's say? Because you can publish a static transform, or, of course, but in a complex robot like this one, ROS always uses one package and one node to publish the TFs of robots like this, which have many links and many joins. Which is that element? And how can I check if it's being launched or not? So let me read your questions here. Check the launch file in simulation workspace. At the URDF file, but I check it and this is correct, says Pedro Xavier. Yes, broadcast TF for all link. Yeah, so that would be an option. Maya Robot says broadcast TFs for all links. I could do that. I could create TF broadcasters for each of the links, but that's a huge work. There's a way which is much more easier in which I can publish DTFs. Could you please explain more on TF? Check the robot state publisher in the launch file. Okay, Pedro Xavier is taking the hot topic into spot. Very good. So the robot state publisher. So what is this robot state publisher? Basically, the robot state publisher is a node, is a program, is a ROS program that reads all the data from the URDF file of the robot and publishes the TFs accordingly. Yes? So it reads. Let's have a look here at the launch file. So basically what we have here is that first of all, I'm putting into the robot description parameter the description, the URDF definition of my robot. Yes? And I'm loading this into the robot description parameter. Then, next, I'm using the controller spawner here in order to start the controllers of the robot. Yes? But this, the controllers, is going to allow me to move the robot, move the arms, move the joints, but this is not going to allow me to publish the TFs. Yeah? This has nothing to do with the TFs. This is only for controllers. This is only for controlling, moving the different joints and articulations of the robot. Then, as someone said in the chat, there is a tool in ROS that we can use, which basically is going to read the data from this URDF, which, by the way, I'm going to open it right now. So here in the PyRobot, inside the PyRobot package, you can see you are going to find a folder which is named URDF. Yes? Here I have it, and in this case, the one which is loading is the probot v2. So I'm going to open this probot underscore v2.urdf. Yes? Let's open this. Then here, when you are in the URDF file, I suggest you to do one thing to see it properly, because here this is displayed as a plain text. Then if you come here, yes, at the right bottom of the IDE, where it says plain text, you can click here, and here you can choose, for instance, XML, and this is going to show like an XML file, yes, and it's going to highlight all the interesting things, yes. Then here, as you can see, we have the description, the definition of my robot. Yes, here I have the base link, the base laser, CPU link, I have defined all the links, the upper base, the torso, the head, the arms, everything, all the robot, all the structure of my robot and all the definition is defined here. Yes? And also, besides the links, we have also defined here the joints. Yes? Here we are starting to have the joint definitions, which basically what do is to connect links. As you can see, we have a joint here which is connecting the base to the CPU. We have here another joint here, for instance, this one here, it's connecting the torso with the head. Yes? So here we have the definition of our robot. Then, if this URDF file is correct, we can use the robot state publisher in order to publish the transforms for us. Yes? And how can we do this? Well, we can come here to the launch file and start a node. Let's do it like this, which is going to be the robot state publisher. Yes? Then the node I want to start, it's the robot state publisher. And the name I'm going to give to this node, it's also robot state publisher. Yes? So from the package robot state publisher, I'm going to start the program robot state publisher, and I'm going to name this node as robot state publisher. Yeah? So super easy. Then here, I'm going to add another argument, which is going to be respawn. I'm going to set it to false. So in case this node dies, for whatever the reason, I'm not going to restart it. Yes? And finally, I'm going to put the output to the screen. Yes? Then I'm going to close this tag right here. Yes? So what am I doing here? Super easily, I'm starting a node, the robot state publisher node. Yeah? Are you following me along? Yeah? So far so good. Let me check the comments here and in the chat. Frames PDF is generated. How to open it? Says Indra Kumar. Okay, yeah, so here you can come and download this file, yeah? And you are going to be able to get it in your local computer and visualize it as you want, yeah? So as easy as that. Then, here I have added the robot state publisher. Then, again, I remember, this robot state publisher program that I am starting here is going to read from this URDF file all these elements, and it's going to publish the transforms between them for me. Yes? Just by doing this. Yes? He's going to take all the hard work for me. I'm not going to need to calculate for each link, each joint, and create a broadcaster for each one. No, no, no. I just start this program, and this program publishes all the TFs for me. Yes? Then, let's do one thing here. Let's come, stop here our launch file, and restart it. So I'm going to restart it, relaunch the probot control, and see what happens now. Alright, so what do you think now? Are we going to have the TFs published? Let me check it real quick here using a ROS topic list, because the transform of the robot are published in a topic, which is like this, /tf. Yes, this topic, if we do a ROS topic echo of the TF topic, is where all the TFs are being published by the Robotics publisher. Then here, if I do a ROS topic echo TF, I am still, let me check one thing real quick. Alright, so I have the topic, so ROS topic info TF. Okay, yeah, here. So if I get information from this topic, ROS topic info TF, I can see here that there is a publisher to this topic, which is the robot state publisher node. Yes? Make sense? Alright, then what I'm going to do now is to generate again, in order to see if my TFs are being generated properly. I'm going to generate again the frames PDF file. Yeah? So let me run this right now. Alright. Let me download the frames PDF file one more time. Open it here. And voila! So now I do have here some things published. Yes? So now I can see here transforms. Yeah? Am I right? Alright, so let's keep going. Now, the thing to do here, the thing we were trying to do is to get the transform between the right-hand link and the base link. Yes? So I'm going to come here and execute this command right now. So okay, so here we are getting still some messages, yeah? So we are not getting our expected output here, yeah? Right? So let's read what these messages are saying. Let's go to the beginning. So here I have them. Okay, so it says, could not find a connection between right-hand link and base link because they are not part of the same tree. TFs has 2 or more unconnected trees. The current list of frames is, here I have all the list of frames with the head link, base laser with base link, right hand, which is connected to the right wrist. Yeah, so basically what it's telling me, this, is that they are not part of the same tree. So if we come here to the tree and we check, we can see here the base link, which is connected here to some links, and separated somewhere here, we have the right, where do we have it? Here, the right hand link, which obviously it's not connected in any way to the base link. Yes? So why this is happening? What do you think? Why this is working like this? Why we don't have them connected? What should I check in order to detect the source of this problem? What should I do next? Let me read you here real quick in the chat. I'm going to switch, by the way, here to my view one moment. So let me go here to the YouTube channel and check your comments. All right. Come here real quick. Right here I have the comments. Okay, TF frames, yup. Why didn't we see anything with ROS topic echo TF? Why didn't we see anything with ROS topic echo TF? Oh yeah, this is because, let me check here. So do you mean with this? Here we are not having anything published, and here, let me do like this. One and ROS topic echo TF static. Yes, so we don't have anything in the regular TF, but we have it in the TF static, because right now we are working with static transforms. Yes, that's why. So as you can see here, yes, we have the TF and the TF static. So that's why, since we have all these separated frames, yes, it cannot detect the proper transforms from here to here, which is the current TF, but it can only show me static TFs, like these ones, yes? So that's basically why. Yep, let me go back to the comments. Missing links in URDF, because of the URDF, we should have shoulder, upper arm, elbow, lower arm, wrist, hand, for both left and right. Okay, yeah, show. Oh, yeah, sorry guys, I was explaining things and showing the camera, so I'm going back here. So what I was saying is that we cannot see anything in the TF because of this, because of all this not being properly connected, yeah? So this is basically why. Then, let me come back here to show, okay. Yeah, so here in the comments, you were telling me to review the URDF, yeah? Are you seeing my screen, guys, now? I can see a message here, we don't see your screen. Can you see it now? Yes, no? Let me know, guys, if you can see my screen. One second. Okay, give me 1 second, because I think I'm having some kind of problem here. Give me just 1 second. Cancel. Okay. Meanwhile, guys, you can try to find by yourself if you find the error. Yes, so give me just 1 second here. Okay, almost there. Okay, let me change here the screen, 1 second. CPU. 1 second. Okay, let me. Okay, one moment, guys, please. Let me check this. And this. All right. Doing some tests here. Okay, let me see how you guys are doing here. Yes, okay. Connect frames using the static transform, parent as base link and child as left hand. Okay, I can see here, yeah, Mara is connect frames using a static transform, parent as base link and child as left hand. Yeah, that's an option, We are going to see this right now, Maya, don't worry. Okay, let me finish having a look at this. All right, so control. Okay. Okay, I can see you are guys already commenting about this issue, so that's great. I'm really sorry, but I had here an unexpected problem that I have to deal right now online. So I'm really sorry. I'm trying to fix it. Give me 1 second. All right, all right. Okay, I see. Control. Come here. Okay, I think I almost have fixed this. Give me just 1 second. Alright, so let me stop this. Alright. Okay guys, I'm almost there. 5 minutes and I come back. So I'm very sorry. So these things only happen in the live events like this one, but don't worry, it's going to be fixed right now. So there we go. All right, so let me close this, let me close this. Let's see. All right. It's done, guys. This is fixed. So let's go back to the live class. I'm really sorry. So let's go. Okay. So okay, you are with my camera. Let me have a quick look at the comments here in the chat. All right. So okay, let me review everything you have said here. Yep, it's the link that connects the upper base link to torso link. In the URDF, head pan link is supposed to be parent of head till link, but it's not in the tree we generated. Yeah, so basically we were having that issue with the TF tree that was not being connected, right? Then, hello. Der Kaput says, hello, I am very late. Is it possible to get the ROS link, please? It's going, I don't know if I have in here. Kaput, I don't know if some of your colleagues can pass the link to their Kaput. It would be nice. There is a joint connecting the upper base link to torso link. This command line is a different type of joint. I have downloaded the URDF and opened it in an XML viewer, and now this is clearer. Okay, great. Would like to see how you are solving issues, chance of occurrence of issues in ROS development. Yeah, it was a thing not related to this. So if it was a ROS related problem, I would have done it. But as Sandy says, Alberto has gone from pretty face to serious face. That's right. Okay, Chelosky, it's a continuous joint with no transmission, and there is a connection. Okay, so all of you are reviewing here the URDF, as I can see from the comments, and checking here. Some of you say it might be these commented lines, which are here, but this is not the issue. So the issue of the disconnected, it's not because of this. Yes, these ones are not used in this case. Yeah, so don't mind about these commented joints here. So you were checking basically, and that's a very good idea. So you were basically checking the connections here with the joints, right? Between the links, in order to try to find out. Sorry, let me change here to the computer screen because I'm talking here. So as I was saying, I saw some comments that you were saying that maybe it's these commented lines, the ones that are causing the problem, right? Also here, you were checking here the different joints, the connection between between the different links, how they are connected, etc. Yeah. So, but I think no one has found anything, any real clue here. Is that right? I think that is the type of the joint. Pero Xavier says, I think that is the type of the joint. It's a continuous joint with no transmission. If change the type for fixed, the PDF changes. Okay, I don't know which joint are you talking about right now. But so let's resume everything as it was. So I'm going to come here. I'm going to launch. Have here my control file. Let me start it here with my simulation. I'm going to run the view frames here one more time to refresh everything. All right, so here we should have now the going to download this, Yeah, so we had this issue here where all the links here, neck link, base link, torso link, all these are not connected between them when they should be connected between them, right? Then you were very correctly, you are checking in the URDF files the connection, the joints that are supposed to connect these links, right? So this is a very good practice, but indeed, the problem could be that. But if you check the URDF, if you have checked the URDF, you would have seen that the joints are there. So for instance, here we have the upper base link. Let me come here to my URDF file, where I have it here. To left, upper base link. Yeah, so here I have the link, and here I have the joint, for instance, which connects, here I have it, connects the upper base link to the dorsal link, right? Then, why, if I have the joint defined here, why this is not showing properly in my tree? Yes, because the joint is there. So I have a joint which is connecting this link with this link, but the connection is not there, right? Then let me tell you that the problem here is, it could be related to this, but in this case it's not. The problem is much more simple than that. So here, let me come here again. So the robot state publisher that we are launching here, as well as all the transform, it's also publishing the states of the joints. Yes? So I'm sorry, I have yeah, so here I have the joint states and p-robot joint states. Then, if I do an info here in the joint states topic, which is a very common and known topic, I see that the robot state publisher is subscribed to it. And this one, the p-robot, in fact, I don't know why it's there. All right, there we go. So do you see something strange here? We have two different joint states, right? The p-robot joint states and the joint states. This topic basically is telling me the state of the joints, which is basically where we are having the problem. The joints are not being properly loaded and seen, yes? Because, for instance, the joint from the upper base link to the dorsal link, it's in the URDF, but it's not properly shown here. Yes? Then what is happening here? So what I can see here is that Gazebo, my simulation, here, it's publishing joint states to the p-robot joint states topic. Yes? This is the Gazebo simulation. But my robot state publisher, which is supposed to read these states from Gazebo and generate all the transform, is reading, it subscribes, you can see here, to the joint states topic. Yes? So we are publishing here data into the p-robot joint states topic, we are publishing the states of the joints into this topic, but our robot state publisher, it's reading this data from the joint states topic. Yes? So this doesn't make sense, because these states here are not going to be the ones of the robot. Yes? So this is subscribing to something which is not the real topic where we have the joint states. Then here, what I'm going to do is to add a very simple remap from joint states to by robot joint states. Yeah? So now, instead of subscribing to the joint states topic, I'm going to subscribe to the PyRobot joint states topic, because the joint states topic is the one by default. But in this case, I am not using joint states. I'm using the PyRobot prefix here. Yes? Then, also this prefix here, I can see it in the URDF, in fact. If I check here, yeah, so here in the Gazebo ROS control, in the library ROS control, we can see that we have a namespace of PyRobot. Yes? So you can find it also here, but I think that checking it through topics, it's more explanatory. Yes? Then I have done this remap here so that I connect now to the PyRobot joint states topic instead of the joint states topic. Yep. Then let me relaunch this file right here. I have something wrong. Oh yeah, sure. I need to close here the tag. Yes, I didn't close it. So remap from joint states to PyRobot. Then we save this and we relaunch our launch file. And now I am going here to generate one more time the TF tree. And let's see what happens now. So let's see what tree do we get now. Let's come here, download this PDF, and voila! So suddenly everything now is connected. We have the base link connected to the CPU, to the upper base link, which is connected to the torso link, which at the same time is connected to the shoulders, the head, etc., etc., etc. Yes? Yep. So all of you, please, guys, here, when you are launching the Robotics Publisher, add this remap. Yes, because in this case, we need it for this to work properly. Yes? Then now, in theory, if I have a look here at the TF tree, doing a ROS topic echo TF, now I am starting to get information. Yes? Remember, before our TF topic was not working properly. Now I am getting here the TFs published. Yes? Makes sense? So let me have a look here at the comments. Let me check here. I don't see Rosjek link, please, der Kapute. Okay, let me put it here one more time. There we go. Yehor Semeniaka says, who is publishing to PRobot joint states? That's a very good question. So, who is publishing? As you can see, the one who is publishing at the... Now, let's do a ROS topic list. Grep joint states. Yes, so now we only have this topic. If you do a ROS topic info of this PyRobot joint states, you can see that the publisher is the node Gazebo. So it's Gazebo, the node Gazebo, the Gazebo simulator, the one who is publishing this, yes, through a library. However, this is too much, I think. Maybe another day we can check more on this, yes. But for now we are going to focus because all the issues, we are already 20 minutes past the time. So I cannot enter now into explaining the details here, but basically you have to know that it's Gazebo. So when we launched the simulation at the beginning here through the launch file, yes, okay, very quickly. So here we used the launch file. So that you can check it yourself, debug day3.launch, yeah. Here you have everything which is being loaded into the simulation. Yeah, here we have the spawn robot v2. You can debug here the launch files and keep checking here all the things that are being launched here and spawned. Yes. So basically it's this Gazebo simulation, these launch files the ones that are starting the plugins of Gazebo that are publishing these joint states. Yep. But maybe another day we will go more deeply into that. So Mikael Trezi asks, do we need robot namespace? Very good question. So do we need this? No, we don't need it. We could remove it. In fact, yeah, but usually it's good to use namespaces in order to better indicate, let's say, to organize better this. So because in this case, we only have one robot, yes? So it doesn't matter in this case, yes? But imagine we have 3 P robots, not only one, but 3 different P robots. Then here I can manage this by setting different namespaces. Yep. All right, so let's keep going, guys. Let's keep going. Okay, so now we have our PDF tree correct, and now we are ready to check here the TF. In theory, we should be able to visualize this properly. So let me run this, the TF echo command, and now I'm starting to get here proper data. Yes, so now I am getting here the translation and rotation as expected. Yes, here we have the expected message, and here we can see that we are starting to get this value. However, here in the notebook is specified, in order to verify that the transform is correct, we will focus only on the translation. This part of the message should be like shown below, with a tiny error margin. So the translation value should be more or less 012, 012, and 017. Yes? Well, minus 012, sorry, minus 012 and 017. Yes? Well, actually, the sign is not that important, but the distance, yes, because it depends if the arm is stopped here or behind. So, basically, we should have 12 centimeters here in the x-axis, 12 centimeters in the y-axis, and 17 centimeters more or less in the z-axis. Then, here we are getting 18 centimeters in the y-axis. Okay, there's a tiny error, it's acceptable. We are having here 17 centimeters in the z-axis, which is also very similar to this, so we are going to accept this, but here it's changing from 12 centimeters to 3 meters. Yes? So there is something wrong here. Yeah, this transform is not correct, because the hand, as we can see here, the right hand, which is this one, it's not 3 meters away from the base. You can see this, yes? So it makes no sense that the system is telling me, the transform is telling me that this hand, this piece here, it's separated 3 meters in the x-axis from the base link. Yeah, it makes no sense at all. Do you see this? That it makes no sense? So, now, where should I go look for? Okay, so now I should really go to check the URDF file. Yes? Because this translation is defined in the URDF file. So, I'm going to come here to the URDF file and I'm going to look for the right hand joint, which I have right here. Yes? So here I have the joint definition from my right hand. Then basically here, I am defining that this right hand is going to be connected to the wrist, which makes sense. And here, I'm defining the origin of this joint. And as I can see here from the XYZ origin, this has an offset of 3 meters in the x-axis. Yes? Which makes no sense at all. Yeah, if we compare it with the left hand here, we can see that the offset is 0. Yes, because this is connected. It's in the same XY axis as the wrist link. Yeah, so the wrist link, it's this one we have right above, yeah? Then, sorry, it's this one, the race link, it's this one, yes? And it's in the same XY axis than the hand. You can see this, yeah? So, this link, it's in the same XY axis than the hand, but it's within a different Z axis, yeah? Then, here I'm setting an offset in the x-axis of 3 meters, of minus 3 meters in fact, which is resulting to put here some stuff. And also, in fact, let's do one thing here, let's analyze it through the RVs, which is going to be much more clear. So I'm going to open a new window here with RVs. Let me do this real quick. And I'm going, in order to visualize RVs, I'm going to open here the graphical tools window. Yes. So another way, and a very good way of checking TFs, is using RVs, of course. Then here I'm going to set the base link as the fixed frame. I'm going to add a model of my robot to visualize it here. There we go. Here I have my robot, my Pi robot, and I'm going to add a TF visualizer. Yes, so here we go. And here I have all the TFs of my robot, which are too much, yeah? However, I'm going to disable all of them, and I'm going to enable the one from the base link. Let me make here the robot a little bit more transparent, so 0.2 for instance, yeah? So I can see perfectly the TF. So here I have the base link frame, and for instance, I can check also the left hand link, which I have right here. You can see it, yeah? It's there in the hand. Then, yeah, so here we can see it better, yes? Here we have the base of the robot, and here we have the right hand, the left hand. Then the right hand frame should be here, right? Where the robot has its right hand. But if I click here on the right hand link, where is this link appearing? It's appearing here, which makes no sense at all. Yes? And this is happening because here, when I am defining this join, I am setting here an offset of -3, which makes no sense at all. Yes? Then here, in order to solve this issue, I'm going to set the X offset to 0. Yep? Okay, so I'm going to save this file, and I'm going to stop this. By the way, since I am changing, let me close now RVs one more time. Let me close as well the controllers. And since I am modifying the URDF from the simulation, I'm going to have to restart the simulation. So I'm going to close it and restart it, launch it again, because I have modified the URDF. Yes? So I have done modifications in the URDF file, which is the one being used by Gazebo. Yes? So that's why, since I have done modifications here, I need to restart the simulation. Yep. Then I have here restarted my simulation, which is starting to load. I'm going to launch again my robot state publisher node here. And now, if I restart RVs here, let me set this again. I have to put everything one more time. So I'm going to now display only the TFs, which we have here. There we go. I'm going to remove all these frames, like so. And I'm going to enable the base link and the right hand link. Well, the left hand link I have it here, and the right hand link, which now, if we zoom here and come closer, not that closer. So if we come here, now we can see that this makes sense. Yeah, so we have the base link here, and at each side we have the left hand and the right hand. Yeah, makes sense? Alright, so now also, if we get the transform, again, using the tf echo command, from the right hand to the base link, we should have something which makes sense, and in fact we do. Yeah? So here, this makes more sense. This is saying that the distance from the base link to the right hand, it's 16 centimeters in the x-axis, 12 centimeters in the y-axis, and 8 centimeters here in the z-axis. Yes? Which, having a look at the simulation, makes more sense. Yep. Alright, so we have fixed it. Let me have a quick look here at the comments. Yeah, says Engineering Nation. I think the problem is visible. The right hand is sitting on the floor 3 meters away from the robot. Yeah, that was true. So that was the problem. We have seen it here because I didn't want to show it visually, but I did want to show how to find the problem using ROS tools. Yeah, not just by seeing it, but in this case it was very obvious. Yeah. So they say this robot is a giant. Yes, this robot is. Well, this robot it's quite simple, in fact, compared to other robots. This is quite simple, but it's very good in order to test all the TFs, links, because it's very easy to see them. Yes? Then, yeah, alright. Yeah, so you are commenting also about the bonding box, which now, the bonding box, as you can see, now it's correct, yeah? Now it fits perfectly the robot, not as before, yeah? Okay, so very good comments here, I can see. Thanks. Why we are changing to base link in global option of Airbit? Okay, that's a good question as well. So we are doing this in order to set a frame of reference here, yes? So you can choose as a reference any other link, so it doesn't have to be the base link. Yes. So for instance, let me add here a robot one more time. Here I have it, and this sets as reference the base link. So for instance, in this case, as you can see, if we set as reference the left hand link, the reference frame is the left hand, yes? If we change to the, the head link, then the reference frame here is the head, yes? So in order to make it more realistic, I'm setting it here. I'm setting the frame to visualize it here as to visualize the base link as the frame of reference, yes? Which is in the 0, 0, 0. Yep, makes sense? All right. So, let's keep going. Then, we are almost there, by the way, yes? Then next thing, check the joint states topic if everything is correct. So I'm going to do this, ROS topic echo p-row, I'm going to copy paste this command here. P-row joint state minus p1, and we should get a message similar to this one with the names of all the joints, as we can see here, and its position, velocity, and effort values. Yes? So this is a normal message. Let me print it here one more time to see it better. Yes? So this is the messages, the type of messages we get here in the joint states topics. Yeah? So it shows me all the joints of the robot and its position, velocity, and effort values. Yes? So this structure is correct, so this is correct. Then one last thing that we have to solve here. So, in order to verify that everything is working as expected, we are going to generate a transform tree for the P robot. For doing so, you need to execute the below command. Okay, so we have already generated here a TF tree, yes? However, this says the TF tree generated should be the same as the one you have in the debug day 3 package. with the name of expected tf3.pdf. So here, inside my debug day2 package, you all have a PDF file which is named like this, expected tf3.pdf, right? So all of you should have this file. Then if I download this file here, and I open it, I get here almost, I can see that it's almost the same, but it's not the same, yes? So I can see in my current one, everything is starting from the base link, which goes to the CPU, upper base link, torso, the shoulders, the head, and it ends here in the hands, yes? So here it's almost the same. We can see that it ends in the hands. We have the torso, the head, the shoulders, upper base, CPU, base link, but all of this is connected to a world frame. What does this world frame mean? Well, this world frame basically it's used in order to connect the robot, the base of the robot, to a frame which is sitting here in the world, in the gazebo simulation, let's say, yes, in the environment. Yeah, makes sense? So it's a way of connecting the base of the robot to the reference of the world. Yeah, to the 0, 0, 0 position of the world. Then this, we don't have it right now. Right? So we don't have this world frame here in our PDF. So how can I add it? How can I generate this frame and connect it to the base link? What should I do? What do you think? Give me ideas. So what would you guys do in order to fix this? Let me know in the comments. Any comments? Let me know. In URDF. Okay, yeah, very good. Indra Kumar says in the URDF. Yeah, that's right. So if we want to change this, well, there are other options as well, but creating it in the URDF is one of them, for sure. Another possibility could be, for instance, to create an static transform publisher. That would be another possibility. Set an XYZ value and connect with baselink. Yep. Publish transform from world to baselink using a static transform. Yeah, that's a possibility. We can use a static transform publisher. Yeah. So we could create a static transform publisher in order to do so, or in the URDF. So, for instance, now, in order to don't create more files, I'm going to do it directly on the URDF. Yes, also because I think it's more interesting, because in the practical, in the real world, it's not very common to use a static transform publisher. Yes, it's much more common to work with URDFs. Yes, so I'm going to do it directly in the URDF to see how this is done. So, first of all, what I would do would be to, let me close these trees. So first of all, I would create here a new link. At the top, for instance here, which I'm going to name link name world. Yep. So here I create a new link, which is world, and that's it. So I'm not going to add anything, because this is an imaginary link. Yes, it's not real. It's an imaginary. It's just a frame. So I don't need to define here any visual, because it's not. We are not going to visualize it. Yes, this is just for reference. Then I create an empty link here named world. Now, in the base link joint, which I have here before this one, I would create a new joint named world to base, for instance. Yes, which, let me close this, which has as parent link, it has world, yes? And as child link, it has base link. Yeah? Makes sense? So we have created at the top here the world link, which is empty, and then here we create a joint which connects the world link to the base link. Yeah? Makes sense? Yes? Then now, if I want this to take effect, I'm going to have to restart the simulation again, like so. Let me stop this, by the way. Let me have a look at the comments. There we go. Here it's loading the simulation. Oh, I have an error here. I have just spotted it. It's not named, it's name. Joint name. Yeah? So let me relaunch here the simulation. There we go. Okay, so I have some errors in the URDF apparently. I have done something wrong. I'm going to recheck this now because here, as you can see, the robot is not appearing. So let me have a look here at what I'm doing. Joint name, parent link, child link. Oh yeah, sure. So I need to define here a type of joint, right? So this is pretty obvious. Otherwise, it makes no sense. Yeah. Then which type of joint should this be? Fixed, because it's going to be always fixed. Yes. It's not going to revolute or nothing. It's going to be fixed. Then I add here the type fixed to this world to base joint. Yes. So now let's relaunch this one more time. And now it should work properly. Yep, so there we have it. There we have our robot being loaded. I'm going to start one more time the robot state publisher here. And finally, I'm going to generate one last time the TF tree here. And I'm going to have a look right here, and I can see that now I have this world frame which is connected to the base link. Yes? And it's being published by the robot state publisher that I am launching. Yep. Okay, so yes, that would be basically it. So we have been checking here several things, issues related to TFs and URDF, which are a complex issue. So maybe some of you have been a bit lost at some moment during the class of today. But yeah, I mean, it's not an easy topic, and it requires a lot of focus. Yeah. So if you are interested in learning more, for instance, you can check here our course about TFs in the academy. Yep, we have here in the Robotics Academy a course explaining everything about TFs. Yes, you can see all the units here, etc. So yeah, let me have a last look now at the chat and see if we have any question. All right. Create a link world and a joint between world and base link. Yeah, that's exactly what we have done, and it has worked perfectly. Yes? So if you want now, you can create, you can do it, you can try to do it as well as homework. You can try to do it instead of modifying the URDF. You can try to do it by creating a static transform publisher, which is also very easy to do. Yeah, so you can try that as a homework if you want, in order to keep working and testing this project. Okay, so yeah, I cannot see any more question here. What is the ID we need to use for real-time ROS? The ID we need to use for real-time ROS robot development. What do you mean by real-time, Maya? Okay, well, ID you can use any you want. I would suggest to you, why not, to use the ROS Development Studio as a development environment. Yes, because here you can have many things integrated. Yeah, you can test the simulations, you have everything here, and you can share it with your colleagues with a simple link. So why not? You can develop ROS using the ROS Development Studio. In fact, that's what I do. Yeah. Okay, guys. So I see that I'm not getting any questions. So thank you very much all. I'm going to finish almost this class has gone for almost 2 hours, but there was an unexpected error from our side, so that's totally normal. That I wanted to finish the content, so that's why I made it last longer, because it's not your fault that we have an error, so you deserve to get all the content. So yeah, we have completed all the notebook. We have been able to debug everything and do everything I had prepared for today's class. Then tomorrow we are going to have another class, so same hour, same time, 7 p.m. It's going to last 1 hour. Hopefully we are not going to have any issue tomorrow. I hope so. So yes, I will see you tomorrow, and meanwhile, stay safe, stay home, and keep pushing your ROS learning. Yeah, so nice session. I can see here some comments. Sandy's were good session, Alberto. Thank you. Nice session. Thank you. Okay, sorry. What was the robot state publisher exactly? Okay, that's a deep question right now. So the robot state publisher, basically summarizing everything. This is what we have basically explained in the class of today. So I'm going to answer this question because of this, because it's like the summary of the class of today. So the robot state publisher is a ROS program, let's say, that reads the robot definition in a URDF, reads the robot structure, and based on the data in this URDF, it automatically publishes the transforms into a topic, so that I can access them through a topic. Yeah? So basically that's the robot state publisher. It reads the state of the robot and it publishes into TFs. Yes? Okay. Thank you, gracias Alberto. Okay, so thank you all. Apologies for this, the period where I was solving this error. I'm really sorry. So, but well, hopefully I could fix it and we could finish the class properly. So thank you very much. I will see you all tomorrow at the same time. Bye bye. Thank you. Bye bye.